Alright, we should be live. Just having a couple chips. Okay. Here we are. I'm just going to put this on Twitter in case anyone wants to check it out. This light beam is very annoying. I'm sorry about it. I'm just in a call room. I guess it's just at the right angle. Okay. I'll drop this on Twitter in case anyone is interested. Alright, good shit. Okay, so let's get to it. So, I had a couple of meetings. They were alright. But I finished them up and I came back here and I spent a bunch of time writing super thorough comments all throughout the source of this library, as you can see. So hopefully, there's a typo. Hopefully this will be helpful for anyone that is looking at the code and wants to contribute. If not, then I tried my best. There's only so much you can do in life. My battery's been struggling, but I think we'll survive here to the end of this cast because we're not covering nearly as much as we were in the first one. We're just going over the single template generation. So I'll start with what that actually is, and also I'm going to see if anyone's here. Oh, one person's here. That's exciting. Hello, one person, whoever you are. I hope that you're enjoying this. We reached our world record, all-time record of 8 people last time. That was pretty exciting. Okay, so let's say that you are pulling down some data for a blog. And you've got a bunch of blog posts and you want to display them on your index page, but you also want to write out an individual template for each post so that you can link to it. This type of thing is a very common use case, and so we have a tool that can deal with that in Spike Records, and we call it single page templates. So you can find it down here in the README. And the gist of it is that for any data source that you give, so you give your source, it's your blog, here's your URL. This could be, again, a file or just pure data if you want. And then you give this template option, which takes 2 keys. The first one is path, which is a relative path to, you know what, this should be SGR because we changed the extension. It should be a relative path to the template that you want to render each item into. And then it takes this output function, which essentially gets the full data per object as it runs, and lets you return the path that you want to output that file to. Of course, again, relative to the project root. So in this case, it would go to your imaginary blog, get all the posts, and then it would read your single template, and it would render each post into one of these templates and output it at whatever the post slug is. Sorry, it's very loud outside again. So that's essentially the option that we're breaking down. And in the source, this is exceedingly complicated, unfortunately. But it gives a lot of insight into the way that Spike works and the way that Webpack plugins work. So I'm excited to walk through it. Also, I just want to mention, it gives you its own transform function here too. So if you need to transform your data specifically for going into your templates, just because templates require you having an array because it will step through each item in the data to generate a post for it, you could do extra transformation if you need to pull off just some posts or something. In the same way that the regular transform function works, just gives you the flexibility if you need it. Okay, so let's get into it. When we last ended, we took a look at this run function and how it went and resolved each of the data types and how it essentially went through ran the transform function in each one, merged those into the add data to object, and then it returned. There were a couple of things we skipped over. The first one was this, and I said that it was something about templates, and we come back to it. Second one is this, which again is something about templates, and I said we come back to it. So let's talk about what's happening here. First, what we do here is we look and see if there is actually a template key on the data that you passed in. And again, for reference, that would be this is your data key up here, and so this could not have this and just have a URL, and that's fine. But if that was the case, then we wouldn't do any of this because we don't need it. And so if there is a template key on there, what we're doing is we're reaching into the Spike options and pushing that template's path, and it's relative to the root again, so we combine it with the root of the project, which can be pulled from compiler options context. This is a Webpack thing. The Webpack sets the project root as context on its options, and all of Webpack's options can be conveniently accessed via compiler options in any Webpack plugin. So we build that absolute path, and then we push that into Spike options ignore. And the reason is because in these templates, you can probably see here, that they get a special local called item, which represents each item that you have stepped through in your responses. So that's how you get the specific data for each post, or item, I guess, is the more generic term, but in this case, for our example, we're talking about blog posts. So you get the example for each post under this item key. And the reason we put it under that key instead of just merging it into the root of the post locals is because each template also still gets all of your regular locals. So if you had like API key that you pass as a local to your reshape config and you want it available in all your views, it still is available in your template view. So we merge those two and we scope these under item because we don't want it to override anything. Honestly, now that I'm looking at it, it probably would be better to do it as like underscore item or something just to make extra sure you have no namespace conflicts. But at this point, I don't want to push a breaking change yet, and nobody's reported the issue, so I'm not going to deal with it. But sure, if I was looking at this again, I probably would want to go to further links to make sure that there are no namespace conflicts there. Because when you merge two different objects, that's a very common situation you run into. This gets some special locals under the item, and so we don't want Spike to see that template file in your project and then go to try to compile it. Because as soon as it does, it'll see the item thing and it will choke on it because we need to render this in a special manner with that item local added in. So I want Spike to ignore the file, and we'll handle processing that file ourselves as a part of this plugin, which we're just about to go through. So that's why we need to push it to the ignores here, because if we don't, we need to say to the user, hey, you have to manually go and ignore all your template files, which is annoying. So might as well just take care of it for them because they're going to have to do it every time anyway. With the Spike ops thing, you can see how they're pulled up here. And this is something that's new to the next version of Spike and is a requirement because of Webpack 2. Let me just check this quickly. Okay, still one person, that's cool. I wasn't expecting as many people because I didn't give quite as an advanced of a warning. I just wanted to have this video on the record for finishing it out if anyone wants to check it out later. So this is a new thing for Spike Next, so if you have built or considered building any Spike plugins, this is probably something that you'll see. And at some point I would very much like to get into the reasons behind why this is necessary instead of just doing like compiler.options.spike. right? Just sticking the Spike config right on the Webpack config, which is what it was previously. And the short reason is because Webpack now validates, and the long reason is the whole way that we get around validation and still tack on Spike's options to the config through alternate methods. But basically, it's a little more complicated to get them, so you can just use the utility, which is a great thing to fire up right at the beginning of any plugin that you're using, and it will pull them off for you. So we get the Spike specific options, which are any options that Spike uses but Webpack does not, which we do have a listing of in the docs. And yeah, we'll just push those into Spike Ignore, because like we said before, Webpack will build its file tree based on requires. So it'll look at your main entry and it will require, it'll read your whole require tree and build its dependency tree based on that. But Spike is different because it'll read your whole project and it will compile all of the files in your project. So it makes it a little bit easier to build static sites because you don't have to have every single file linked somehow to this one main JavaScript file. You can just have an HTML file, it'll compile that, and you don't have to do anything special. And that's one of Spike's main advantages when it comes to building static sites with Webpack, because it adds that extra utility on top where like not everything has to go through your JavaScript files. But it still takes advantage of the Webpack plugins and the compiler and everything like that. At some point we'll do a video walking through how Spike works, because it's really very simple and it's not that many lines of code, and it's pretty well commented already, but I'll make sure it's very well commented because I'd love to get people in there contributing to that. It's very accessible and straightforward. So that's what we're doing here, and then here we just save off these locals because what's happening up here, and we notice we only hit this method and we kind of ignored these two because these two are specifically for dealing with this single template thing. And so when we actually write the templates is down here in the emit hook, which is when everything's already done compiling and it's starting to write out files. So this is the right time to render our files and pass them off to Webpack because this is when Webpack's like exposes its infrastructure for accepting new files to its own render pipeline. So since this happens in a different hook, we still need to have these locals available because we are going to be rendering them into the templates. But since the templates are rendered down here, we can't just, we're going to lose them if we don't save them off somewhere before we exit this hook, which is what happens in the next step. So just put them on this object, and then we can pull them back out later. So this is just saving off the locals, and locals represents all of the resolved data that came from this, okay, and was transformed, right? And you can see that merge into locals is where we talked about this in the last screencast. This is where we add data to, and you can see that this is under tap. And tap is something that's specific to Wen.js. I really wish it was added to the main promise spec, and maybe it will be someday, but it's very helpful. It's essentially the same thing as then, except no matter what you return from it, it will still make no difference. It'll return the same thing that came back from the previous promise. So it's almost like you jump in there and like run a side effect, and then keep it rolling, you know? So whatever this function returns, it won't affect this next one at all. It just does its thing and it keeps the same input and output no matter what. So we're still getting what we had after this one, which was the resolves data put through the transforms. This goes off as a side effect, and then this still gets the same input. Called that locals because it's going into our locals. And so then we just save that off to this object and finish up. Okay, so now we're back up here. We finished with run all, we're done, we're good to go. And now we have this next step, which deals with the loader context. And so I'm gonna skip this for now because it'll be more relevant when we come back to it later in context. But essentially what it's doing is it's jumping in at a specific step that Webpack has for when it is kind of dealing with its loaders, and each loader has a context that's passed to it where the loader can access certain values like the options and the name of the current file that's being processed and things like that. So if you're writing a Webpack loader, you probably will need to utilize some of that information. And so we actually do need to utilize that information later to render the templates. So we jump into that step and also save that off to this object so it'll be available. Okay, and we'll come back to this. So now here in the emit hook, this is the hook where it's writing out its assets. If you want to add to the assets that it's going to write out, this is the place to do it. And you can read more about this on the Webpack docs. They have really great docs. The next version of the docs for Webpack 2 are fantastic. Oh, 2 people, nice. Okay. And this is a great page where you can read up on how the plugins work, how the compiler and compilation stuff goes down. It's very, very helpful. And if there's anything on here that's confusing, I've gone through this a lot, so I would be totally happy to. Is this a Gitter link? Oh, this is interesting. Wow. Very cool. That must have been recently added. Okay. That's very cool, actually. I like that a lot. Maybe we should add that to the Spike site to get like quick questions. Okay. Distraction. So it's great. If there's anything missing or confusing, let me know, because I could probably pull requests a fix into here, and that would be a good time. Spike giving back to Webpack, as Webpack has given so much to Spike. Okay, so that's how you figure out what's going on in these hooks. But basically, this is the hook where you're going to add files for Webpack to write. So this is where we compile our templates and give them to Webpack to write out into our public folder. And so again, we're seeing keys map here. And this is a very useful method when dealing with this type of structure. But we're taking the locals, which we saved off earlier. You remember this. So now we're able to access them from here. And we're going through each of the keys and each of the values. And if the values are promised, it'll resolve. So for each one, we're calling this write templates function, and we're binding 2 arguments to it. We're binding the compilation and the compiler. And the reason is because these are both things that we need Webpack values from. And they're available here, so we want to make them available to this function when it's called as well. So the first 2 arguments will be these 2, and then the next 2 arguments will be the key and the value off of this data. So let's jump down to this function and see what's going on. Again, I've written a big, extensive piece on this, and I'll talk you through it now, but if you're coming back later, it should be helpful. So here we have the compilation compiler, the value, and the key. So just as expected, good stuff. And so now in this function, our goal is to go through for each key, and if it has a template option, we need to start rendering templates for its data. So first thing we do is check to see if it has the template option, where we go this options key template, and if it doesn't, we're out. We're just returning right away, and we don't have to do anything else. If it doesn't have a path or output, then we can't really do any rendering because we don't know what your template is, and we don't know how to output your template. So we're going to throw an error here if that doesn't happen. So this is just our upfront checks to make sure everything's good. Okay, and next we check for that transform function if it exists. If you need it, we'll run it. So here it is. And if not, we'll just return the raw data. And so this is our final state data that we're going to be rendering into each template. Now, at this point, we need to make sure we have an array, because what we're doing here, again, is we're going through each item in an array, and we're rendering a template for each one. Each blog post in your blog, each staff member in your employees, API, whatever it is. So it needs to be an array, and so we're going to run a quick check and make sure that that's the case as well. And once we're sure we have an array here, now we can start doing some good stuff. So first, we go into async mode here with node.call. Again, this will coerce a node method into a promise because we use promises a lot in the source for Spike and its ecosystem, because they're a much better way to handle async than callbacks. So we'll run this read file as a promise, and we'll read out the template path because we need that source in order to render it. And we come back with a source, the template. Now, given that template, we go through each item in the array that we have of, let's just say, blog posts for context. Okay, so we have this array of blog posts, and we're going to map through each item here. And we have the template source available to us, so we're ready to get this data rendering into that template. Okay, so first thing we're going to do is set up the actual information that we're rendering in. So each item of data in the array of blog posts, we come through into this map function as item, and then we conveniently assign it to add data to an item. And then we also add the file name here because sometimes you need to reference what template you're in. So just for clarity, everything else comes with a file name, so you just want to keep it there. So that's that. And now we have our adjusted data object. And now that I'm looking at this, honestly, I do think that it would be a better plan to do something like this. Rather than mutating the original object, I think it would be better to make a new object that is a compilation of what we want. And I will make that refactor, I think, but I'm not going to do it while we're on air because it's getting a little late and I want to make sure this is finished within a reasonable amount of time. But if the reasons for that make sense to you, then good. If not, I'm happy to talk more about that. Just let me know. And I'll check for questions now real quick. Okay, 2 people, no questions. Good. All right. So let's keep it running. 21 minutes, goodness. All right. Oh, wait. Come on, get crazy. I would. But I want to get through this explanation at least first. Okay, so I'll have some chips. How's that for getting crazy? Go wild. So, this is the part that gets interesting. And I'll try to explain this in a way that makes sense. And I think probably we'll have this fully covered in the next 10 minutes, which will keep this to half the length of the first one. Just kidding. When we render this template, we're going to do it as much exactly in the way that Webpack is internally rendering our reshape templates as possible. We need it to be an exact clone of that because when you configure Spike, you pass your options to reshape. Your plugins, your locals, like all the settings that you need for reshape, you have those configured in your file, and you expect those settings to apply to all of your views, including these templates, right? And the thing that parses these templates and generates them is the reshape loader, because that's how Webpack deals with templates. Every file that comes in, it goes across your rules. Now in Webpack 2, they changed it from module loaders to module rules. It sees if the path matches any of the regular expressions that are in your rules. And if it does, it'll pair it with that loader. That's it. So all your reshape templates are matched using loader. And so we want the exact same settings to apply to these templates, or else you'll run into situations where you're like, okay, I had this plugin that was coming in that I need to use for like include or for layouts. It works for all my templates, but it doesn't work for like this single page template coming out of Spike Records. Why is that the case? Does that make sense? He asked to nobody, and nobody said nothing. Okay, so we'll see if anyone said anything. Nope. All right. So what we're going to do is essentially load, I wrote the reshape loader, so it makes it easier for me to make this modification. But I knew that this would be a use case, so the reshape loader's option parsing is separated out and exported as a separate function in case anybody needs to use it for a separate purpose. So we actually required reshape loader as a dependency here. And luckily it's a very light dependency because by far its heaviest dependency is reshape, which we're already including, and npm will even out those two dependencies, so it's not really anything extra. It's pretty much just this option parsing function. So we call this option parsing function, and if you noted in the tests, right, back to the tests we go, we have, let's go to the part where it does reshape things. Okay, HTML standards. Okay, so we have this HTML standards thing, and under the locals, if you remember from the last time, we talked about the reason that this is a function, right? So it could be just locals like this, and that would be the empty object. But that would just set it to being that empty object right here. Rather than that being the case, we need, when it's ready to compile, we need it to return the object that we want. And so we set it to a function, and the reshape loader goes through and it calls the functions before it's going to compile in order to get out the right object. And what it does is it calls this with the loader context, okay? And we don't use it here, but there are some things that do use it. For example, Spike page ID uses it because the context lets us see what file we're currently on. Like what file are we compiling? And so this is available as a parameter to all the functions here in HTML standard. And actually all the functions in reshape, even if you don't use HTML standards. Any kind of key, you can have the value be a function, and anytime your value is a function, it gets the loader context as a parameter. And there are times where you need some of your plugins and maybe some of your locals to be able to access this information, right? So we need to have this context available and call it correctly. So what we do is we call parse options, but when parse options happens in the loader, we have the loader context available and make use of it. So we need to call it with the loader context. The way that loaders work generally is that, let's see, I'll just open it up. So reshape loader, we'll boot this up. And this is kind of like a tangent, but we'll keep it quick because we're getting deep into like how Webpack works, which I think is relevant for more people than perhaps Spike, but still. So, sorry, that was not what I wanted to click on. So in a loader is very simple actually. It just exports a function that takes the source of the file that's being loaded, or rather compiled here. And you can do what you want with this source, and then you just return your modified source. So if you got in some Jade or SugarML, you would run your compiler on it, and then you would return the modified version. That's it. It's very simple. Loaders are super simple, much easier than plugins. And they're very powerful too, actually, so it's great. And here's where you call back. So the callback, if there is an error, you pass the error as the first param, and then as the second, which is a standard node pattern, and as the second param, you would just pass your results. So here's where we run it with reshape and call the resulting function with locals, and that's the results. Okay, but you can see that this comes up a lot here, and this is the context of the function. That's what this is called, and this is where parse options is called, right? And so you could see that parse options is exported here, and this is the place where it kind of like does its thing. But it's important that it has the right context when it's called, because when it does this convert function is where it decides whether it needs to call your function or whether it's not, as you can see. If it is a function, and then this is your function, this is where it calls it with the context, right? And this is the context because we've bound it all the way through. So when we call this, we need to also have the loader context, the correct loader context, in order to get a one-to-one match of our options. I hope that makes some sense. I know this is going really deep. Let's see if there's questions. Okay, makes sense. Cons are like, yeah, everything seems to be like a couple of seconds behind. Okay, so that was why we did this work up here, because in order to get an accurate build of these templates, we need to run them exactly like the loader runs them, and we need to have the loader context available for any possible functions in the configuration. So we have this separate little hook here, just so that we can dive in and we can just grab the loader context. And the only way I figured this out was just trolling through the Webpack docs and the source, trying to find, like, where does the loader do its thing and where can I get the context from. And this just happens to be the hook where you can get it. And Webpack is great in this way in that it really has an extraordinary amount of hooks all throughout its compile process at every single step. It's got hooks so you can come in and get the information you need, which is great. So that's why we took this detour up here, just to get that loader context. And so now we have it, and our hard work started to pay off because we can call this with the correct context. And then we just go again to get the spike options and just pull the reshape options back. And so what we've got here essentially is an exact copy of the options that the loader passes into reshape internally. But we're doing it manually here because we need to do this custom, we need to set it up with some custom locals. And so for that reason, we can't just put it through the Webpack pipeline without going to some real extra pains, which we could get into now, but I won't. Okay, low battery. Okay, so now we've really gotten over the most confusing part of this, which is that in order to have a correct run of reshape with the right options from your configuration, we need to parse those options with an accurate loader context. In order to get the loader context, we needed to come grab it in a separate hook. So we grabbed this loader context in a separate hook, we saved it away, and now down here, we put it to work by having the options parsed exactly the same way as they are for every other file in the project, and get the correct options back. And now the rest is pretty much easy coasting. We run reshape with the right options, we process the template, which we read up here, the source of, and then we take the output, and reshape outputs a function so that you can use it client side if you want, or you can just execute the function with your locals to get back an HTML string. So we execute the locals, get our HTML string, and then here's the final crown jewel, the cherry on top. Webpack has, on its compilation object, specifically in the emit step, which is what we're running this from, it has a property called assets, and you can tack on any path that you want to the assets as long as the value is a function for the source and a function for the length of the source. I'm not sure why this is here. Honestly, it seems like poor design because instead of making me do this every time, they could just take the result of that function and then call .length on it. But aside, it is how it needs to be for Webpack at the moment. So that's what you pass in. And then here's the last little piece is where we call that output function. So in order to figure out what path you're outputting your template to, we just pass in all of the locals from that specific item. You render your function, you give us the path, and it will run this up relative to the project root. That's it. This little piece down here is something I could spend another 30 minutes on, but it essentially has to do with race conditions. And I think that it might actually be resolved by the fix that I proposed up here. And we'll report back on that. But essentially, it's going through this as quickly as possible, that since this is async and these don't run in series, they run in parallel, what's happening is that the locals, if you didn't bind the correct locals to this function specifically, the locals would change out faster than the templates rendered, and you get the same locals for every template, which is annoying. And I know that that wasn't a very good or thorough explanation, and I could go into that in the future, but I just want to call it at this now that we've explained through the whole plugin, because it's getting a little bit late and I've spent a lot of time today screencasting, and that's pretty much it. That's the whole thing. So we've gotten through the end. Now my computer froze. Oh, we're back. Hey, okay. Thank God. Okay, so that's it. That's the whole source. That's the end of the apply method. And after we're done writing the templates, which is async again, we call done to let Webpack know that we've finished up with our work in this hook, and that's the whole thing. So thank you so much again for tuning in. Very much appreciate it. It's good for me to go through and explain these. I hope you'll go check out the source and tinker around with it a little bit. Very, very thorough comments again here for all the methods explaining all this stuff that I was explaining in person. Probably what I should do is actually link up the videos of this in the source or in the README somewhere. So maybe I'll do that. And I'd really like to get to a place where all of the parts of our ecosystem here for Spike and Reshape are commented this thoroughly, and to a point where I'll slowly go through and run explainers and question answer sessions on all of them, because I really want to encourage people to really dive into the source here and start learning more about some crazy JavaScript and start contributing, because nothing feels better than contributing to an open source project, especially one that you use and that you enjoy. So that's all I got for today. Thank you again for checking this out, and we'll be back with some more exciting screencasts someday in the future. I'll check one last time for questions. Give it a quick moment. I guess until I can see myself after the lag. If there's anything else here, it looks like there's not. And we have 2 people. Cool. You are most welcome. Okay, so that will be that for the screencast, and thanks so much for tuning in. See you guys later.